Hello guys, in this video I'm going to show you how to solve rearrange string k distant apart. So given a string and a number k, if the string can be rearranged such that the same characters are at least k distant apart from each other. So let's take a look at it. For example here, we're given this string mpp, which is 4 character long, and k is 2, right? So we need to rearrange, right? Such a way the same characters at least k distant apart. So two same character must be, in this case, two distant apart, which means here we have is the same, pp is the same, so it must be m, then something in the middle, and m, right? And also p, it should be p, something in the middle, and p. So here is two distant apart, right? So uh, with these two constraints, there are two way to rearrange, which is MP, PMPM, or PMPMs, right? So there could be multiple ways to rearrange, right? So here you can either return one of these. Okay. Okay, let's take a look at a more complex example here. Okay, we have AAA, BB, CD, and in this case, our K is, let's say, uh, 3. Okay. Firstly, let's try to do it manually. What character are you gonna uh, let's say we're trying to put the character uh, try to do it manually here, right? Here we have 3A, 2B, and CD. So what character are you gonna put it first here? So for me, I probably go for A, and let's try to put it so you'll see why. Um, so A first, right? So I don't know what I will put here, but I will leave it empty. So I want to make sure that A characters are 3 distant apart from each other. We have 3 A's, right? So as long as we could end up with something like this, then we're good to go. And okay, we're done with the character with that appears most here, which is A. So let's go to B. Okay, so we have seven character here, and here we have 3A and 4 empty places, which is also 7. So as long as we could uh, put all the remaining characters into this empty slot, then we're done with rearranging, right? Okay, we are left with BBCD, right? So let's try to put the one that is uh, appear the most here, which is B. So if I put B here, and another B um, must be three distant apart. One, two, three here. Right? So here is another B. So now we're done with A and B, right? So we're left with C and D. It, um, so now we're left with C and D, and all have each has frequency of one, right? So you might notice that we could either put C here or D here, C here, or the other way is still fine, right? Here could be D, or here could be C. So can we make observations here? So as you see, what we're trying to do here is to allocate the character with high frequency first, right? And then uh, as you can see, we'll go from A, B, and then C, D. And as you can see, the characters uh, with um, smallest frequency, in this case D and C has one, appears only once each. And with C and D, we the its positions is doesn't really matter here, right? We could either put C or D, or D or C. It still satisfies our constraint, right? Which is characters are the same, must be k distant apart, right? But for the case that is um, for the case that is A, for example, we couldn't uh, have that kind of flexibility, right? There's no way to for me to find another place to allocate A in this case, right? A would be fixed, right? There's only one way to put A here, right? So essentially, we need to prioritize the high frequency character first. This leads us to uh, a data structures that is optimized for these operations, which is a heap, right? In this case, max heap, because we want to extract the character. We want to know at any time what is the character with high frequency. So uh, let's first count frequency of each character first. So let's say A is 3, we have 3A here, and then we have B is 2, right? And C and D is 1, and D 1. Okay, and when I have finished counting frequency of each character, then I'm gonna put it inside a heap. here is a maxim, right? Here is a maxim. Okay, so let's simulate what we was doing here. Okay, first is to take out the, okay, but first let's uh no, you need a 7 empty slots so we can put every character inside here one by one. Okay, first a in 3 we take out the character with high frequency first, which is a in 3 here, right? Okay, so this one is out and I will put it 1A here. So I take 1A out of here, it means we end up with uh, 2A, right? So what we wanna do next? Uh, you're probably thinking that wanna take B2. Okay, let's try to do that. Okay, B2. Oops. Oh no. Okay, B2. Okay, B is out, and I will take 1B here and put it in here. So we need to update. So we only uh, left with 1B, and the next L will be C1. Okay, okay, C, and need to update it here. The frequency of C now 0. So as you can see, the next here should be A, and it means that we must uh, we must bring back these item into the heaps in order to um, to be able to take it out again, right? But the problem now is, let's say when I first take a initially a3 out, and if I put it back right away, and obviously it become a2, right? It's still the largest high frequency. So if I take it out once again, I would have AA next to each other, which is something I don't want. So probably we must have a way so that we only put it back when we have put in here two characters. Right? So when we have here B and C, and then only at that time I will put it back A2 here. So the next one that come out is A, so I can put A here. So for this kind of operations, the data structure that is fit in this case uh, is a queue, right? Because it helps us to store the items uh, in order that 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 they are, because it is uh, first in and first in and first out, right? So it will be clear uh, when we use a queue here now. Let's say, so here is our queue. Here is the, it will go out this way and go in this way. So here is actually the order that we take out the items, right? A, B, and C. So at this point is the time that I want to put it A here back to the queue, so I can have A out once again, and I put A here. So as you can see, right now the size of the queue is 3, which is equal to K. So the observations here is that when the size is K, it is the time we put it back, the item at the head of the queue, right? So that we maintain K distance apart between A here, right? Okay, so now I will put it back. Let's say no, but let's do it one by one. A back. Okay. Okay, let's move these to the head. C0. Okay, the next step is to pop out the item with high frequency in the heap, which is again I2. Let's put it outside first. Okay, A2. So the one that is out is A. So I will put one A here. It means I left with uh, one A, and then I will put it back to the queue. As you can see, the next should be B, right? And it means that we're gonna put B1 back to the heap, because now the size of the queue is again 3. Okay, B back. And now let's try to adjust our queue bit so we have space for new item. Okay, so the next item that come out here could be B or D, but let's say in this guy you wanna go for B. Okay, B1. Okay, the new item is B, so I will put B here. It means I need to update its frequency down to 0, and then I will put it to the queue, to the end of the queue. Right now, again, our queue is of size 3. It means I need to put it back, the item at the head. But at this point, mm, C is 0. It means we'll use all the C. We've used all the C that we have, right? We have only one C and we put it here. So there's no point to put it back, right? So now it means that I would just remove C0 here. Okay. Mm, let's adjust it a little bit. I1 and B0. Okay, the next item that is out is D1, right? Here's the only thing that we have in heap now, so I will take it down. D1 out, so I need to uh, put the 1D in here. It means that I will need to update the frequency down to 0. Oops. So after that, I will put it in at the end of the key. And now the size of the queue is 3. It means I will consider put back the item at the head of the queue to the heap, right? I1. Okay. Alright. Okay, A1 will come out once again. So A is out, so it means I will put one A here and frequency of A will go down to 0 before I put it back. I push it at the end of the queue. And as you might see that we're done with our final string, final rearrangement, and everything in the queue has frequency of 0. And for all of these items, when I just uh, pop it out from the heads of queue one by one, and we're not going to put it back to the lock heaps again. So we are done now for our algorithm. Let's try to turn everything here into code. Okay. We need to count frequency of each character first, then put with frequency into heap, right, into a max heap, and then we need a queue store at max cây item, and we need to take out one by one from max heap, right, and put item put into current string, let's say, and we also consider to put back. No, and then uh, after we take out the mark heaps, we build our current string and wanna push item into queue, right? And then what else? We may want to uh, uh, consider adding back item to max heaps when queue is of size k. Okay, and finally return current string. Okay, first up, for count the frequency of each character, we probably need a map here, which is just the objects. So for each character of the original strings, I'm gonna check if it is not, if the character is not in the frequency, then I will initialize the frequency of character to 0, and then right after that, update the frequency by 1. So after that, I'm gonna, okay, I'm gonna iterate to every key in the frequency map. In this case, character, right? Frequency. And for each one, I'm gonna add in my max heap. Add. The thing that I'm gonna add here is, let's say, for one item, I need the character itself and also its frequency. So the max heap know how uh, to extract the character with high frequency first, right? Okay. So item here is just an array. The first element is character, and second one is frequency of that character. But I don't have a max heap yet, so I need to initialize is a new heap. Initialize empty, and the third argument here will decide whether it is a max heap or its min heap. And because it is a max heap now, so it will be a minus b. But ab is actually the item. So the thing that I want to return here is a1 and b1, which is the frequency of the item. So this will help the max heap to determine what is the character with high frequency now, right? Okay, I need a queue. In this case, it's just an array. Okay, take out one by one from the max heap. This means as long as the max heap is still there's something inside, I want to, let's say, item max heap is pop. We take one out from max heaps, and here is a item with the high frequency right now. So I will build my current string. Let's say current string initially is empty, and here is something you want to return at the end. Okay, I will build my string. Assuming that the frequency here uh, is is positive, is greater than 0, right? So currency, current string, I'm gonna build up with the latest character, which is item at index 0. And after that, I will push this item to the queue but because we have contribute one character into the constraint, so the thing that is pushed in the queue is actually the character. The character is item at index 0, and the the frequency must be decremented by 1. And then we'll consider adding back when the queue is of size k. Okay, if queue length is k now, it means that I will take out one item from the head of the queue, uh, item back, say candidate. We're not sure to add it back. Let's say candidate queue ship. This candidate may be may has may have frequency of 0, right? So we must check only if candidate has frequency is greater than 0. Only in that case I will only in that case I will add it back to the max heaps. And here I will add back a candidate. Okay, I think we're done. Let's run the test. We have one failing test. Because there could be the case that we couldn't build our we could not arrange in such a way that satisfies this requirement. So in that case, we will return empty string. Right? So how I want to check that? Can be easily checked by compare the length of constraint with the length of original string. And if it is not the same, it means we couldn't build a string, a complete string, so it return a empty string, else I return good string. Okay, we're done. So that is it for this problem. Thanks for watching. See you in the next video.